Right. Right. Okay. So let's look at number one. We're finding the measure of angle A, and we've been given all the different angle measures. We know C is 60, B is 54 plus X, and A is X plus 84. So how did you set up an equation to start solving this?
Did 84 plus X
Mm-hmm.
plus 54 plus X plus 60
Perfect.
equals to 180.
Perfect. So 84 plus X plus 54 plus X plus 60 equals 180. Perfect, perfect. All right, what'd you do next?
I combined like terms.
Absolutely. So what like terms do we have here?
84, 54, 60.
Awesome. And so you added those all together?
Yes.
Okay, let's see. 84 plus 54 plus 60. Did you get 198?
Yep.
Perfect. So 198 plus what else?
Combine the two X's.
Perfect. Did you get 2x? Awesome. So 198 plus 2x equals 180. Then what did you do?
I subtract 198.
Perfect. Let's do that. So 2x equals, let's see,
Negative 18.
yes, negative 18. Okay, so what'd you get for x? Perfect, that is correct. So x equals negative 9. Now, how are you going to use that to find the measure of angle A?
You replace the X and the X plus 84, negative 9.
Perfect. Here, I didn't number this. So we did negative 9 plus 84. And what'd you get for your angle measure?
75.
75. Perfect. So angle A was 75 degrees. Good job, Ella. Okay, how about number 2? This one was a little bit easier. How'd you set this one up?
70 plus 60.
X plus 70 plus 60 equals 180. Okay, then what'd you do?
Combine like terms.
Yes, 70 and 60. What's that give us? 130? Okay, that's what I thought. 130.
We have to write down.
Yes, thank you. Okay, and what'd you do next?
I subtracted 130.
Perfect. Minus 130. And you get x equals, what'd you get? 50. Perfect. Perfect, perfect. Okay, so you got that down. That is wonderful. So here's what we're going to talk about today. We are going to talk about triangle side lengths. We've been talking about angles a bunch, but we haven't talked about the sides yet. So something we're going to learn about today is that the sum of the lengths of any two sides of a triangle must be greater than the length of the remaining side. And that's going to make a lot more sense once we kind of visualize that. And then we're also going to talk about right triangles and how to use the Pythagorean theorem. Have you ever seen this before? A squared plus b squared equals c squared? Yeah. So that's something we'll probably play around with a little bit today. Okay, so I'm going to see if it will let me like share my screen. I don't know if I'll be able to put this part on Google Classroom. Anyway, what I'm going to have you do, Ella, and anybody watching is go ahead to Google Classroom. Okay, let's see.
got my notebook open just in case we didn't notice.
Yes. Okay, so when you go into Google Classroom, let's see if it shared it to my stream. Okay, so you'll see a new assignment once you get in there. Hold on while we're getting that ready. Okay, so one of the things we're talking about is what I just said for the first topic about the triangle side lengths. So basically, if we have a triangle and I know that one side is, we'll use the first example they gave us on the website. One side is 32, one side is 19, and one side is 52. Here's how we can tell if these will make a triangle. Basically, we have to do a couple little math problems here. I'm going to call these A, B, and C. So I need to make sure that whenever I add A plus B, that I get a number that is bigger than C. So let's try that. 32 plus 19. What's 32 plus 19?
51.
51. Oh, okay. So if I get 51, is that bigger than 52?
No.
No, it is not. So are these three sides going to make a triangle?
No.
No. Okay, so let's go to that website. Let's click on no and see what happens. So here's how we can see. I'm going to drag this, drag that. See how since these two sides aren't adding up, these lengths are not long enough to ever touch each other. It's never going to be able to make a triangle. Let's try another one. How about these three? Let's see. I'm going to set up our little equation again. We've got 42, 13, and 46. 42, 13, and 46. So I need to make sure that when I add any of the two sides together, that they're bigger than the third side. So let's try 42 plus 13. Yeah, so it is going to be bigger than 46. So that works. Let's see. Let's hit yes and see if it can make a triangle. Yes. It can. Okay.
Very weird one.
Yes, a very strange triangle, but it does work. You can make a triangle with it. Perfect. Okay, let's try another one. New problem. I've got 39, 15, and 59. 39, 15, 59. Okay, how can we check if these three segments are going to create a triangle? Yeah, let's add those smaller angles up, or not angles, sides. Let's add the smaller sides up and see if they add up to be larger than 59. So 39 plus 15 needs to be greater than 59. Let's see what that is. 39 plus 15. I got 54.
That's what I got.
Yeah, so is 54 greater than 59? No, so that's not going to make a triangle, is it? Okay, let's see. No. Ah. I drag them around, we'll be able to see that that is definitely not going to work. Not at all. Okay, let's do one more of these. Okay. Last three we got here. It is in a different order. 43, 28, and 17. So which two of these sides do you think would make the most sense to try adding together? Yeah, why'd you pick the 28 and the 17? Yes, you always want to be working with the two smaller sides to make sure that they're adding up to that larger side. So let's add them together. 28 plus 17. Are they greater than 43? Let's see. 28 plus 17. What'd you get for that? Perfect. 45. Is that greater than 43? Yes, it is. So we can say that yes, they form a triangle. Perfect.
It's really hard to put them together into a triangle.
I know. They kind of have it thrown all over the place once you hit yes or no.
I'm trying to get them aligned, but
I
okay,
know
there
it.
it goes. Finally aligned.
Perfect.
What
Okay.
to do if the dot has to fully connect? Well, it does go extremely tiny when you do
Yes,
the dot.
it does. Yes, it does. Okay, so we've explored a little bit with that, and we can see, and you know what? Let me see if I can show at least on the camera a little bit, because anybody watching this is going to be really confused. I'm going to put this over here and make it upside down. Okay, so this is what we've been looking at. I probably should have done this the whole time. Oh my goodness.
Oh, they're seeing the string?
Oh, how can I make this not? Let's do this. Okay, there we go. So I'm going to move this over here. That way only you see. Ha, ha, ha. So here's what we're looking at. The three segments form a triangle. Let's do another one just so they can see what was happening here. One more. New problem. One more. Okay, so let's figure out if these three make a triangle. We've got 35, 26, and 16. Which two sides do you think we should add together?
The 6 and the 16.
Yeah, the 26 and the 16. And they just need to be bigger than 35. Are they going to be bigger?
Yep.
Yeah, they are. So these do form a triangle. Yes. And we check by dragging these around to see what. Oh, yep, we can do it perfectly. Just about.
Just arrange it a little more.
Yeah.
Just arrange a perfect dot.
Almost perfect. I know it's kind of tricky to get it right exact. Close enough. Okay, perfect. All right, so I feel like visualizing it definitely helps. It makes it make a little more sense because whenever you just think about adding them together and making sure they're greater than, it almost seems a little abstract, but seeing it on the screen makes, at least to me, it made a lot more sense. Okay, so now we have done that. Let's do a little bit of practice without the visualizer. So I'm going to give you a couple of sets of numbers that I want you to try and solve on your own. Tell me if they're triangles or not.
Back up.
Yes, that'd be perfect. Okay, so what if I give you some smaller sides? So here's a question. What if I give you side lengths 2, 2, and 4? How are you going to tell if these make a triangle or not?
As ups and choose.
Yeah, we want to add up the two smaller sides. So let's see. 2 plus 2. If it's greater than 4, then it will make a triangle. It won't. Why not? Yes. 2 plus 2 equals 4. If I have a side that's 4, oh, that's a little wiggly. And then I have another side that's 2 and another side that's 2, those are never going to make a triangle. When we close them up, it's just going to make a flat line. It won't work. It won't work. All right. Let's try something else. Let's talk about right triangles and the Pythagorean theorem. So I'm going to have you at the top of this page. Let's title it A squared plus B squared equals C squared. And we're going to draw a right triangle. And can you remind me, what does a right triangle have to have?
90 degrees?
Yes, perfect, perfect, perfect. You need to have at least one 90-degree angle. Can it have more than one 90-degree angle?
No.
No, it cannot. That wouldn't be a triangle anymore. So I'm going to draw about a 90-degree angle. And then are going to connect the two. Okay. So on a right triangle, we've got three kind of moving parts here. We've got our two sides right here that are making up the 90-degree angle. And then we've got the third side, the longer side. Now, we always, when we're using this formula, our A and our B are going to be these legs, the parts that make up the 90 degrees. And then this third longer side, yes, this is called the hypotenuse. Hypo, hypotenuse. Hypotenuse. This is what we call our C. Always going to be C. The other two are A and B. Perfect. So the hypotenuse is always directly right across from the right angle. So if I had a right triangle, let's see, and let's say I did not know what the measure of C was, but I knew that A was 3 and B was 4, like this. We could then use this A squared plus B squared equals C squared to figure out what the measure of C is. So I'll let you get your stuff drawn and then we'll work through this first one together. You just tell me when you're ready. All right. So here's how we're going to set this up. All we're going to do is remember that our A, we'll call that 3, our B, that's 4, and C we don't know. So let's plug that into that Pythagorean theorem here. A squared plus B squared equals C squared. So if A is 3, then I'll write 3 squared plus b squared or 4 squared equals c squared. We don't know c yet. Okay, so now that we got that, let's go ahead and figure out what 3 squared is and what 4 squared is. So 3 times 3, what's that going to give you? 9. And then what about 4 squared? 4 times 4. 16. Perfect. Equals c squared. Now let's just add 9 and 16 together. See what that gives us. You tell me, what do you get when you add them together? 25. Perfect. Equals c squared. Okay, so we're almost there. C is not 25, but c squared is 25.
But you have to do like the radicals.
Yes, girl, you're ahead of the game.
Opposite of squared is the radicals.
Exactly. So if we want to know what c is, we know c squared is 25. To get rid of that squared, we need to do the square root or make it a radical. Absolutely. So let's find the square root of both of them. So what would the square root of c squared be? What does that square root do to the 2?
Gets rid of it.
Gets rid of it. So we have c by itself now. Now we just need to find the square root of 25. You remember how to do that on your calculator?
Second x squared.
Yes, and I'll show that on here in case anybody doesn't remember. Second square root, yeah, 25. And what's our answer? 5. So yes, c equals 5. That means our missing side here is 5. Perfect. Perfect, perfect. Now, it's not always going to come out nice and pretty like that. These problems give us a lot of decimals. That 3, 4, 5 always works out kind of perfectly. So let's try another one, maybe one that's a little trickier. So how about I give you another right triangle. And this time, I'll make the bottom line 10. We'll make the side over here 5. And then I want to solve for c. So how would we set up an equation to solve for c here?
Do 5 squared plus 10 squared equals c squared.
Yes, you are so smart. 5 squared plus 10 squared equals c squared. We just got to figure out those numbers at the beginning. 5 squared. 25 plus 10 squared. 100 equals c squared. Okay. What do we do next? Perfect. What's 25 plus 100? 125 equals c squared. Okay, and what's our very last step here? Yes, do the radical, do the square root on both sides, and let's see what that gives us.
Decimal.
A decimal? Okay, let's see. Square root of 125. Ooh, big old decimal. Okay, so I have c by itself now equals Let's go to the tens place, or the tenths. So the first decimal point. If I have 11.18, would I round up to 11.2 or down to 11.1?
Right up to 11.2.
Perfect. So C is 11.2. Awesome, awesome, awesome. Okay, so let's try another one. Maybe get a little harder this time. Wonder if we can figure it out if we have, I'm going to go to the next page. What if we know C squared? We know the third angle, or not angle. I'm going to keep saying angle. We know the hypotenuse. We know the third side. But let's say we have one of the legs missing sides. So I'm going to draw it again. And let's say that the hypotenuse is 25. And let's say that this side over here is 10. So this time we would need to solve for B. And once you get that ready, we'll talk about how we'll set this equation up. All right, so how am I going to set this up?
B1 squared plus B squared equals 25 squared.
Perfect. 10 squared plus B squared equals 25 squared. Exact same thing. It's just that our missing number is somewhere different now. So what do you think we would do first now that we have this all set up?
Squares.
Yeah, we want to find those squares. So what is 10 squared?
100.
100. Bring down my B squared. And then, let's see, 25 squared. That's going to be a big one, isn't it? Yeah.
625.
625. Okay. So, what do we do from here?
Subtract 100.
Yeah, you're awesome. I don't even have to teach you. You're just doing it yourself. That's amazing. Okay, so we'll subtract 100 from both sides. And we'll be left with B squared equals what? Perfect, 525. And how are we going to solve for B now?
Square root.
Exactly. We're just going to do the square root again. So let's figure that out. Square root of B squared, square root of 525.
Wouldn't that be 2.9?
Absolutely. That's exactly what I got. So B equals 22.9. Perfect. 22.9. Awesome. 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 Okay. Let's do one more like that. Making this lesson go so fast, girl. You're just killing it. It's amazing. Right, right. It's not too tough. So let's try, let's do something like totally outrageous here. How about I make like some crazy numbers. Let's make the hypotenuse 13,426. And then let's make let's make our B like 12,200. and then you're going to solve for A. Yeah, there won't ever be questions like this on a quiz, but I think this is just too easy for you. We got to make it interesting.
Oh, you're giving me dream my big number.
Yes. Okay. So, how are we going to set this equation up?
A squared plus 12,200 squared
Uh-huh.
equals 13,426.
Perfect. Okay, I'm scared that these numbers aren't going to fit on the calculator screen.
That's okay.
Here, actually, let me pause this. I'm going to give you a fancy calculator. Oh, all right, so here's the fancy calculator. On. So let's figure that out. Ooh.
Now I gotta find out where those little lines go.
Oh no. Okay, let's see. Oh, the commas. 1, 4, 8.
I got it. 1, 4, 8, 6, 0, 0.
Yes.
Now
I
I
always.
move that over so
Uh-huh.
you don't fit on my page.
Right. And I always like to go from the end of the number backwards when I'm trying to look at where the commas go. So 3 zeros, 840. There we go. So that is 148,840,000. Let's do the other one.
Ooh. 1, 3.
Tell me if you get the same number I got. And do you know where the squared button is on your calculator so you don't have to type it twice?
Yeah.
So that might save you a little time.
Okay, now let's see what we do. Okay. 0, 7, 4, 7, 6.
Perfect. All right. What do we do next?
Subtract.
Yes, we do. So let's subtract. 1,
I'm not
4,
saying these
8.
numbers because they are way too big. We need this big.
Yes. And you know what's kind of nice? What'd you say? I know.
Lining up the triangle and everything.
Let me see if I can remember how to do this. So what's nice about these calculators is you can use the up and down arrows, and I think you can select numbers and not have to retype them. So let me see. Let me just write, okay, minus, and then I think I can go up and yes, you can select it and hit enter. So that'll save us both some time.
Yeah. All I gotta do is write stuff.
Yeah, I know. Writing it is the tough part. 148,840.
Okay.
Okay, let's see what that gives us. Another big number. Okay. So a squared equals.
I can't go up. Well, go up.
It won't let you go up on yours? Are you sure? Here, let me double check it, because you should be able to. All right, what number did you get?
Is 3, 2, 0.
Oh, you got a 2? I got a different number than you, I think. I got 3141746. What number did you get?
I got the 320000, 000.
Okay. So did you do 180
Oh, I see what it is. My
257?
number is mixed up.
Ah,
Tampered with it.
okay, I get ya.
That's the one I have sometimes.
That's okay. These are big numbers. I'm I'm like setting you up to make mistakes. No big
Yeah,
deal.
apparently.
No big deal. So just make sure we're doing the 180 million number minus 148 million number.
So that's how I had to clear my board.
That's all right. So now we've got the same number. Once you get that written down, what's our last step going to be? Yes, square root of both sides. Now let me show you a trick so you don't have to type it in again. So what I'm going to do is get my square root first. And then instead of typing the number, you're going to do this. Okay, ready? You're going to push the up arrow. See how it's highlighting my big number? And then I'm just going to hit enter.
And honestly, it's not working fine.
It's not working with yours? What's it doing when you hit the up arrow?
Same thing.
It just isn't going up? Okay, let me look at your calculator again because maybe I need to get that one looked at. Let's hit enter from here and see what number we get. Little decimal here. What did you get on your calculator?
605.129437.
Perfect.
Which
So
would
if
be 605.1 because 2 is smaller than 5.
yes, exactly. So our answer is 5,605.1. Beautiful. All right, girl. I think you are a master of geometry because you are killing these problems. I feel like I barely have to teach you. So let's go ahead and just get you your exit ticket. That's all we need to learn today. So, yes, our exit ticket today, it's day 13. Day 13 exit ticket. And it's November 18th today. Oh my gosh. This year is flying. I can't believe it's almost, what is it, 2024? It's almost 2025. That's insane. Okay, so I'm going to give you a couple problems for your exit ticket today. The first one, I'm going to say determine if the three side lengths form a triangle. And I'm going to give you two of those. First one will be 31, 27, and 65. And then the second one will be 17, 12, and 47. There's the first two. Then we're going to use the Pythagorean theorem, or a squared plus b squared is c squared, for the next one. I'll just give you one of those. So use the Pythagorean theorem to determine the missing side length. I'm gonna draw a triangle. I won't give you crazy numbers this time. That was kind of mean.
Could have been worse.
Yeah, you're right. Could have been worse. Let's go with 30. And let's solve for B.
At least you know that something may be wrong with one of the calculators.
Yes. Oh my gosh. I'm gonna have to figure out how to fix that. Okay, so that is your exit ticket, 3 problems, and when you complete it, you are good to go. I'm gonna end that recording and upload it to YouTube.